AI systems can inherit biases from the data they are trained on, and those biases can come from the human-generated data. Humans are not perfect and can introduce their own biases consciously or unconsciously when creating or labeling data. Consequently, AI systems trained on such biased data can potentially exhibit biased behavior. Addressing biases in AI systems is a complex challenge that requires careful consideration and ongoing efforts. It involves ensuring diverse and representative training data, implementing fairness metrics, and employing techniques like bias mitigation algorithms. While it is challenging to completely eliminate all biases, progress is being made to minimize their impact and make AI systems more fair and inclusive. It's worth noting that biases are not inherent to AI itself but rather a reflection of the data and algorithms used to train and deploy AI systems. AI can also be harnessed as a tool to identify and mitigate biases in various domains, such as in hiring processes, loan approvals, and criminal justice systems. Ethical guidelines and regulations are being developed to promote responsible AI practices and mitigate bias-related issues. In conclusion, while AI can be influenced by biases present in human-generated data, ongoing research, development, and ethical considerations are focused on reducing and addressing these biases to create more unbiased and fair AI systems. AI researchers and developers are actively working on various techniques to minimize the impact of flawed or biased inputs in AI systems. Here are some of the approaches being employed. Diverse and representative training data. AI developers aim to ensure that training datasets are diverse and representative of the real-world population. This involves collecting data from a wide range of sources and perspectives to minimize bias and promote fairness. Data pre-processing. Before training an AI model, data can be pre-processed to identify and mitigate biases. This can involve techniques like data augmentation, where the dataset is augmented with synthetic examples to balance representation across different groups, or reweighting data to reduce the influence of overrepresented groups. Bias detection and mitigation. AI systems can be designed to detect and mitigate biases in real time. Techniques like algorithmic auditing, where the outputs of the AI system are regularly analyzed for bias, can help identify and rectify biased behavior. Fairness metrics. Developers can define fairness metrics that measure the impact of AI decisions on different demographic groups. By optimizing AI models to minimize disparities in outcomes across these groups, fairness can be improved. Counterfactual explanations. AI systems can provide explanations or counterfactual reasoning to highlight how a decision might have differed if certain variables were changed. This can help users understand the factors influencing AI decisions and identify potential biases. Ethical guidelines and standards. Organizations and research communities are developing guidelines and standards for responsible AI development. These frameworks emphasize fairness, transparency, and accountability, providing guidance for developers to address biases and ethical concerns. User feedback and iterative improvement. Collecting feedback from users and stakeholders can help identify and rectify biases in AI systems. This iterative approach allows for continuous improvement and refinement of the models. It's important to note that addressing biases in AI is an ongoing process that requires collaboration across different disciplines, including AI research, ethics, and social sciences. Efforts are being made to integrate multidisciplinary perspectives to ensure AI systems are as unbiased and fair as possible.